Lesson 4, Describing Transformations Precisely. Students translate, reflect, and rotate figures by hand on a square grid. That's what we did today, and we're going to the practice. So let's head over there. So let's read the summary. Can I make this bigger? Yes, I can. Do I want to? No. So translations, right? In order to do translation, I need a couple of things. I need to know direction. Are we moving up and down or down? Or am I moving left and right, and the number of units? Okay, so everybody in the figure, and all the points in the figure move the same direction, the same amount of units. Reflections. I need the line of reflection. Is it a vertical reflection over a vertical line? Is it the reflection over a horizontal line, a diagonal line, as you see in the picture? And then a rotation. Just remember that when we rotate, we're rotating around a fixed point, and we're rotating in increments of 90 degrees. I know that one's a little bit tough to do it on a grid without the x and y axis. So yeah, that it'll be easier when we do it on a coordinate plane. I promise you. All right, first one. Translate this figure to move point P to P prime. All right, so we're moving the figure. Oh, I think I can do this. So that point. So now I know there isn't one, but I'm going to label the other ones. I'm going to call this E. I'll call this K, and then I'll call this. Well, actually, I'm not going to call it anything because it's not allowing me to write. So let me do this. All right, so I'm going to call this point K, point L, and point Z. I don't know, I made it up. So point P, just to help me out, point P moved 1, 2, 3, 4, 5, 6, 7, 8, 9. So this was a translation, 9 units to the right. So I'm going to take point K and do the same thing. Point K goes 1, 2, 3, 4, 5, 6, 7, 8, 9, and here's where point K, but we don't call it K, we call it K prime. L, 1, 2, 3, 4, 5, 6, 7, 8, 9, and L is right there. And again, we don't call it L, we call it L prime, so we can distinguish the original point from the second. And then this one goes 1, 2, 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's point Z prime. So now I connect the dots. I have that same shape, right? And this particular parallelogram was shifted 9 units to the right. That's it. Hopefully you did a neater job than I did. 3, rotate around the point P. So again, remember for a second what rotation is, right? I want you to think of rotation. Here is, and here is, I don't know, can I get a triangle here? Yeah, I can. So let me draw a triangle. And pretend the triangle is attached right here. So I am going to rotate this triangle, okay, around this fixed point. So if it rotates, and let's try to see, look at that, rotate, no we can't, that's not, no, because it's not, so if I do that, it's not rotating around that point, right? So I really want you to see that this should be traveling, this triangle should be traveling like this. And then I'll show you on this side, right? It should be traveling like that around, right? Around that fixed point, in which case is this one. So here's a parallelogram, which is going to be traveling around this fixed point called P. So one thing we can do to help ourselves here is to cheat. And I'm going to make this, right? I'm going to make this line, and I'm going to make this line. So what you're going to learn very soon every time you rotate 90 degrees, right? You rotate 90 degrees, whether it's counterclockwise or clockwise, you move one quadrant over. So rotation 90 degrees, this shape here, it's going to end up here. If this was rotated 180 degrees, this shape would be over here. And if it was counterclockwise 90 degrees, it would be over here. Okay, so that's what you need to know. I don't even know how to talk about this because it says rotate this 90 degrees counterclockwise. So counterclockwise means we're going to go this direction, right? So if you had that, so let's say you had an arrow that's pointing like that. When it rotates 90 degrees, the arrow is now going this way. Right? If that initial arrow rotates 180 degrees, it would be that way. So this, so imagine that's an arrow, which is pointing, and I don't know, let's just call it, it's pointing that way, needs to be now going like this. It's going to rotate 90 degrees, so this is going to come over here. And let's see what it looks like. So let me just take that. I'll draw the arrow later. So this point stays. But this point over here is going to travel to here. Right? Because remember, this shape, the rectangle, who is now like this, right? If it travels, okay, it's going to look, I'll tell you in a second. 1, 2. So if I were to rotate this, I think I can rotate this, can I? Yes, I can. Look how it's going to look. Right, it's going to look like this now. Okay. So if you want to turn your notebook, and see what this, right, just like I did, you can do that. This point right here. Now I'm going to put some letters. Let me put some letters. So let's call this point L, let's call this point M, and let's call point N. So point P stays there, it just rotates right over, right? So here's point P, let's call it P prime. So it's right in the same spot as P. Point N, if you notice this is going to be my point N. It ends up being right here. Point M, as this figure shifts to the right here, ends up being 1, 2, 3, 4 here, M prime, and then this is what L prime would be. And if I were to connect the dots, look, the same figure, a point in a different direction, right? I know, the rotation is a little bit tough. On a grid without numbers, yeah, that's tough. So don't worry too much about that one. I promise that it'll be better when we have the numbers. Reflection is not bad. Reflection is not bad. So now again, to make my life easier, right? Things I'm going to do to make my life easier. I'm going to give these names, right? What are these names? It doesn't matter what name. I'm going to call A, I'm going to call this B, and I'm going to call this C. So let's start with point C. Point C is 2 units away, so if you count here's point C, and if you count the distance that it is from the mirror, which is the line M, its image would be 2 units on the other side of the mirror. Right, so pretend there are 4 people here, and they're on one side of the mirror. Well, the guy, Carlos, over here, would be the closest one. Peter, who is all the way in the back, would also be in the back. I forgot the prime. So Peter prime, his image on the other side of the mirror, would also be 4 units away from the mirror. So again, when you're doing your hair tomorrow morning, look at yourself in the mirror. You move closer to the mirror, so that's your image. You go further away from the mirror, so that's your image. Okay. B, it's 2 units away from the A, it's 1, 2, 3, 4. So its image will be 1, 2, 3, 4. Also 4 units away. So now, if you connect, right, there's that reflection. 5. Translate the figure. So remember, translation. We need two things for that. We need direction and the number of units. So don't be fooled by the fact that it looks like it moved this way. No, it didn't. The translation is left and right first. So point C actually traveled, well, there's two ways, but let's just go. Point C traveled that way first, and then it went down. Or if you wanted to, it'd say, hey, no, I'd rather point C travel south first, down, and then to the right. It ends up being the same thing. So it's a matter of choice. So whichever one you want. Let's say that point C traveled. Slid, right? Translated. Translation for point C is that it went 1, 2, 3, 3 down, and then 1, 2, 3, 4 to the right. That's how point C moved. And again, if point C moved 3 down, 4 to the right, everybody here is going to move the same way. So go to point B, go 3 down, 1, 2, 3, and 4 to the right. 1, 2, 3, 4. Call it B prime. Point A, 1, 2, 3, 1, 2, 3, 4. Here's point A. Point E, 1, 2, 3, 1, 2, 3, 4. E prime. D, 1, 2, 3, 1, 2, 3, 4. That's called D prime. Now all you gotta do is connect the dots. There you go. Everybody traveled 3 down, 4 right. By translation, everybody moved the same amount of spaces in the same direction. 6, I think. Reflection. Okay. So again, I don't know how you want to think about it. It's, again, you can. It's pentagon, something that has 5 sides, or your 5 friends holding a rope, right, in the shape of a pentagon. There's Edward, there's David, there's Carlos, there's Brian, there is Anna, right? If that was a mirror, line ends a mirror, where would their images be? Well, that's just simply a reflection. So Edward here is 1 unit away from the mirror, so his image would also be 1 unit away. We call it E prime. David is 1 unit away from the mirror. His image would also be 1 unit away from the image. Alex, or Anna, sorry, 1, 2, 3, 4. 1, 2, 3, 4. Anna is 4 units away. So is the image. Brian is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is where Brian prime would be standing. See, Carlos, 1, 2, 3. And then on the other side of the image, 1, 2, 3. Here's C prime. So your reflection on the other side of the mirror. Okay. Sorry, I think no, it's okay. Everything's okay. 7. Or actually, slide 7. How did this become that? That's the question. What transformation was used to take the shaded rectangle, to flip, turn, rotate, slide, to become that one? So let's go one by one. A reflection over the line T. So if this was reflected over the line T, its image would be here. That would be the image. So it's not, right? So a reflection over line T would have ended up with this rectangle, not this one. So reflection is incorrect. a double reflection maybe. So if this got reflected over here, right, and then you took this and reflected over here, then that might be okay, but it doesn't say that. A translation of 6 units down and 4 units to the right. Well, let's take x. Did they go 6 down and 4 to the right? Well, 1, 2, 3, 4, 5, 6, yes. And then did it go 4 right? 1, 2, 3, 4. Now, x only went 6 down. Did it go right 4? No, it didn't. So that's incorrect. Right, so a rotation 9 degrees around point Y. So here we're rotating around this point. So I'm gonna do a line here because that's gonna help me see things. So, right. So we're rotating that rectangle around this point Y. It says so it first says you rotate the rectangle in blue 90 degrees clockwise. So clockwise means we're going this way. And 9 degrees means that this would end up somewhere over here. But if you rotate a rectangle, think about, let me draw a rectangle. A rectangle, yes there is. So think about rotating a rectangle. So if you rotate that rectangle 90 degrees, it is now like this. So, and it would now be here in this area. It would be, as you can maybe say, standing right on this shorter side, and it'd be in quadrant 1, but it's not. Definitely not that one. A rotation 180 degrees clockwise around point Y. Well, guys, let's think about rotations again. So this would be a 90-degree rotation clockwise. And then another 90. And then another 90. So if we start here, so think about a 360. When you do a 360, or the guys in the skateboards, right, are doing a 360, they're literally going one like this. They're turning all the way around 360 degrees once. That would be one. And this shape, if you were to rotate it 360 degrees, sorry, 180 degrees, I take it back. Oh my gosh, I meant to say 180 degrees. So that's my original arrow. Let me put this arrow. And you said rotate 9 degrees clockwise. This would be the result. Rotate the beginning arrow to 180 degrees clockwise. It would be that. So this rotating 180 degrees turns out to be this way, okay, around the point Y. So the last one does work. Eight. Sorry, what does 8 say? Spire, match each expression with an equivalent expression. Is that what it says? Okay, so, oh my god, so I'm going to actually have to do this. Negative 5.7 minus 5.9. Who is that equivalent to? Well, it's not negative. It's positive 5.7x minus 5.9. These two look the same. Yeah, because 1.8x and 3.9x is 5.7 minus 5.9. So those two are the same. This one cancel, negative 3x plus 7. So right here, these two match are the same. And this one will be this one because negative 3 plus 2.5 is negative 0.9 plus 5 steps, and those two match, and obviously these and these are the leftovers. Alright, so that's it for the fourth one, right?